Hi, everybody. Thank you very much for joining us today. I'm going to get us started in the brief time that we have available. Today, we'll be talking a little bit more about getting into the career of engineering. Our panelists today include Andy Nurbin, who is Director of Engineering New Product Development at DRS Power and Control Technologies. We also have with us David Routier, USM class of 2014, who is currently serving as Associate RF Microwave Design Engineer for Northrop Grumman. And also Meredith Short, USM class of 2015, who is working in the Technical Engineering Solutions team with Epic Systems. So I'm going to turn it over to our panelists, beginning with Andy. And we'd like just to know a little bit about how you got to where you are, what you do on a day-to-day basis, and where you think you and your industry are going, and any tips you have to pass on to students who would like to follow in your footsteps. Andy?
All right. I'll get to it here then. So on the question of how I got to where I am, I guess when I was in high school, I was good at science and math, and I like to tinker with things and build things. So I figured engineering was probably the right spot for me. So I got accepted to Marquette University. And it was originally in the industrial engineering program, but throughout my college journey, I discovered that I liked mechanical engineering classes a little better. So I switched partway through my sophomore year to go down that track. And so I graduated as a mechanical engineer. And one of the key things I decided to do in college that got me into the workplace and ultimately to where I am today is I decided to participate in Marquette's co-op program. And in fact, I co-op at the same place I'm still working today. It was called something different 25 years ago, but it's still the same place. And that really paved the way for me getting a job there after college. So I took that internship in co-op as a manufacturing engineer and turned it into a mechanical engineering position when I graduated, and then progressively worked my way up through the ranks at my organization. Through mechanical engineering. For a brief time, I was mechanical engineering manager, and then ultimately was promoted to director, where now I oversee many programs, the technical execution of new product programs, as well as get involved with business development and proposing new projects and working with the government to figure out where our technology could benefit them. So day-to-day duties, they're quite a bit different now than they were when I first started out, more than 2 decades ago. But today I do far more, I wouldn't call it engineering. It's a lot of management or engineering vicariously through others, as I sometimes like to joke about. I've been in my industry a long time and have gotten to know the customer base and the requirements very well. And now I mostly mentor and guide others through their execution of the work, as opposed to me doing it myself. Day to day, I interface frequently with senior management regarding the operations of programs to new opportunities. So I've grown much beyond just the classic engineering role, really a business leadership role at this point. And 20 years ago, I wouldn't have envisioned this was where I would end up. It's just been a journey for me, and being open to new experiences, and not being afraid to try and go, expand your role beyond your swim lane. And I think that's one of the things that's a real benefit of an engineering degree, is it trains your mind to think critically and solve problems, not just to be an engineer, but really to solve any problem that's in front of you. So there's lots of engineers, they graduate and maybe they never even practice engineering, but it's trained their mind to work a certain way, which is advantageous in many careers outside of engineering as well. Where do I think my industry is going? I work in the defense sector. So it's an interesting industry. It doesn't always follow the peaks and valleys of the commercial world, which can be good and can be bad. We've had some of our best years when the economy is down elsewhere, and we've had some of our slowest years when commercial industry is booming. It really just it follows the defense procurement and and budget cycle of the government. So that adds a layer of complexity and unpredictability. But my industry also allows me to work on things you see in the news every day, things of national interest. Some of the systems we produce, you see those platforms out in the world, and you know you're making a difference for your country, and that offers a real sense of fulfillment. So some tips I might offer for those who would follow my path. If you have any opportunity to engage in team activities, I think this is maybe something that's undervalued. At least it used to be when I was going to college, is designing things as a group. No one goes out there and designs something on their own in a vacuum. You're always working with a group of other people, sometimes from multiple disciplines. So I'm a mechanical engineer, but I work with electrical engineers, software engineers, and systems engineers all the time to design these complex products. And really learning how to do that and operate in that team dynamic where there's multiple competing interests and trade-offs and pros and cons that affect multiple different disciplines and really the greater system. It's pretty powerful to get exposed to that earlier in your career. I think one of the better examples of where you can find that environment is the robotics program at USM. I've helped out a couple of days last year with those events, and it's really a microcosm of everything engineers are exposed to on a daily basis. There's a set of requirements for the machine. They have to go figure out how to build the machine within those requirements, and then there's all sorts of trade-offs. You know, there's probably 1,000 different ways you can design that robot, but there's pros and cons to each of them, and you have to work through that process and figure out what's optimal. And that's really what engineering is every day. So seek out those experiences, whether it's being in the robotics club or just getting some tinker time in the innovation space. Don't be afraid to roll up your sleeves and play with things and make things, and don't be afraid to fail a few times. That's how you learn. And I think USM is very powerful that way. It has those opportunities. You just make sure to take them when they're presented to you, and it can really set you up for down the road. There's a great experiences. We like to see that sort of stuff on people's resumes when they come through the door, especially when you're hiring new grads right out of college. Those with those experiences going back into high school, showing you've been through some of those trials and tribulations. Those are what sets your resume apart from many of the other ones that come across people's desks.
Thank you very. And I'm just going to jump in before you speak, David. Bob Duranich, our own USM teacher, is joining us as well, and he'll be talking a little bit more about different classes and opportunities students should be thinking about who have potential interest in engineering. I also invite any students who are watching, if you have particular questions for any of the panelists, please jump in and use the Q&A feature shown at the bottom of your Zoom screen. We will field as many of those as we can at the end of the program. And I will turn it back over to David.
Thank you. So I guess I'll start with how I got to where I am. I've always been a tinkerer ever since I was a young kid. My parents hated it because I would tear apart the house tinkering. Where I really kind of found my stride was actually at USM. I can't remember if it was my sophomore or my junior year, but Mrs. Lusick had this idea for kind of a student-run Genius Bar at the school. And that kind of morphed into a larger idea, and I ended up being one of the co-founders of the House of Technology. And that's kind of really where I found what I enjoyed. I always knew I was going to be on an engineering path, but I didn't know what I wanted to do. So being able to have that experience really kind of put me on the path of electronics and that sort of thing. And I ended up, really my senior year, I figured out, hey, I want to be a computer engineer / electrical engineer. And I'm definitely more of a hardware focused person, but I went the computer engineering route because this is the 21st century. Anything that historically was analog pretty much has digital components now. So understanding that interface between the two is insanely valuable. And so that's where I decided to go to Rochester Institute of Technology, and I double majored actually in computer engineering and electrical engineering. So I got pretty much everything from hardware, RF courses, circuits, electronics, even like power distribution and that with the electrical grid. I got the software side with higher level languages like Java and Python, and the low level stuff, actually interfacing with the processor. So C, assembly, learning how to work with memory maps and things like that, which has really helped me with my current job actually as well, because I'm a integration and test engineer. So we are actually in the labs trying to figure out why things don't work, because they never work the first time. Thus the need for integration and test. So we'll get, I guess I should start with how I got to where this job. RIT is a little bit of a unique school in the fact that all engineering programs there are 5-year engineering programs. And what it is you do your standard 8 semesters of classes, but you also do 2 semesters of co-ops. So when you graduate, you basically have a full year of work experience already when you're ready to enter the workforce. So my first internship co-op, I did a summer with Spectrum, the cable giant, and that was more of a software kind of DevOps role, which I enjoyed it, but it really wasn't for me. And that kind of set me on the path of, hey, I definitely now know for sure I want to go down the hardware route. So then at RIT's career fair the next year, I saw the Northrop Grumman booth. I talked to them. I got an internship again for that summer. I was a little bit more hardware oriented, but on the interface between software and hardware, how do we use software to control the hardware? And I enjoyed that. Still wasn't exactly for me, but also in my department, there were, the integration and test department is kind of a subset of that department. And I saw what those interns were doing. So I asked to come back for a full 8-month co-op. And I asked specifically to be integration and test for that. And that's where I found that INT was my dream job. So day to day in INT, we do anything from designing test fixtures, test equipment, figuring out how we can safely test things, working with these high power RF antennas. It's very easy to set the building on fire. If you're not careful, you can definitely harm yourself with these high energy antennas. And so it's a lot of how can we test this safely. We typically run our antennas at an extremely low duty cycle, so they're only on a fraction of the time they would normally be on. And so we do anything from that to actually designing how we're going to test it to troubleshooting it. And that's a large part of the job is, you know, we have this antenna in the range. Well, now we have to talk to it just to be able to even control it. So that's software there. How do we get the software to talk to it? How do we troubleshoot the software so we can convey back to the software team what's not working and what needs to be fixed? And then typically we'll also run into hardware issues where, you know, something's not working correctly or something was designed poorly. So we have to work with mechanicals to troubleshoot why did this fail? What can we do to fix it? We then go on, once we actually have it functional and are talking to it, we then go on to testing it, performance validation, things like that. You know, why are we not seeing the specs we're expecting to see. A lot of the time it's control issues, which goes back to software. Some of the time our test methods are made some bad assumptions and we have to update those. And it's just a big iterative process working with everybody, the software team, the systems guys, mechanicals. You really work with everybody in my role. And at the end of the day, we eventually get these antennas through the range, they meet all the performance specs, and we can sell them to the customer. As far as where I think my industry is going, I too am in the defense industry. We are, my specific subsector of Northrop Grumman is a lot more of sensors and arrays and things like that. So we're more heavily into electronics. So we're an area that's probably just going to keep growing as things become more and more digital. You know, where we used to have to fire a missile or something at somebody, we can now just beam an extremely high power RF beam at something and it'll neutralize the threat. And so a lot of that, plus communications. My two jobs right now are satellite communications jobs, and everything is connected. Everything needs data transfer. The entire world is digitizing. And so I think I'm in a good sector here that's positioned for a lot of growth. And I know right now we're winning so many jobs, we cannot hire people fast enough to staff them. And finally, tips for people to follow this path. Engineering school specifically is hard. USM is hard, engineering school is harder. Just make sure you're focusing on your academics, don't get behind. You will get behind, but there's also an amount of learning how to manage how far you are behind in each class so you still make all your deadlines. Definitely get involved with activities and things. Don't try to spread yourself too thin, but have a few things that you like to do. Like for example, I was in the pep band and I played intramural hockey at school. And you will need those things to blow off steam because it is stressful. But the end goal is so rewarding. And once you actually finish school, it gets much easier. Engineering school was the most stressful part of being an engineer for me. So.
Thank you, David. And then Meredith, right over to you.
Yeah. So I'm Meredith. I'm technical solutions engineer at Epic. Kind of how I got to where I am, similar to Andy and David. I took an interest in math and science courses from a young age in middle school and high school. So I kind of always knew that I wanted to do something in STEM. And once I got to college, I thought that the engineering path was right for me. I really loved knowing how things worked in the world around me. And just digging into problems and getting my hands dirty that way. So I thought that engineering was a good fit. I originally wanted to do biomedical engineering. I had an interest in pre-med and engineering and did not want to do both. So I thought that biomedical engineering was a good blend. I eventually switched gears and took up mechanical engineering, and that's what I ended up getting my major in. And I thought that that was a nice way to still allow me to go into the medical field if I wanted to. I felt like mechanical engineering was just one of the broader fields where I could explore a lot of different paths since I didn't necessarily know what I wanted to do. And engineering in general just opens the door for a lot of different things. You don't necessarily have to go into engineering with an engineering degree because you'll apply a lot of the skills that you learn, like your problem solving, and you can apply those to virtually any job. So I studied mechanical engineering and also did a certificate in energy and the environment because I was really interested in renewable energy. I did a study abroad program that focused on that. And that's kind of when I solidified the fact that I really wanted to go into renewable energy. Right now, I'm not in renewable energy, but I still see it as a possible career path for me down the road. But currently, I work for Epic, which is in Verona, Wisconsin. They're a healthcare software company that focuses on an electronic health record. So if you ever go to the doctor's office and you see them charting or ordering up a vaccination, anything like that, they're using an electronic health record, a system like Epic. So kind of on a day-to-day, I am a problem solver is kind of the best word to solve it or to sum it up. So I work with 2 different organizations and work with their healthcare IT staff and help them troubleshoot issues. So if there's a problem with the code, we try to identify where they ran into it, what sorts of fixes we have available, whether it's development or otherwise, and how to stop our customers from running into that problem, but also other customers that I don't necessarily work with, but who use Epic. We also help implement projects that they might be doing. So as you can imagine, we had some COVID related projects this year that we helped our customers implement so that they could do rapid testing, mass clinics, and eventually the COVID vaccination workflows for that. And I also do some small development projects. We have software developers who do some of the larger development projects, but as a TS, I'm able to get myself into developing code as well, which is nice. I didn't have a strong coding background, but have since learned since starting the job. And so where I think I and my industry are going, as far as the healthcare industry, I think that there will always be around. And one of the things that I think we'll kind of be going towards is actually a byproduct of coronavirus, and that's telehealth. So some of you may have had video visits with your providers during this time, and I think that will be interesting to see how that evolves into our everyday life. I think that will become more and more of a thing and more of an option going forward post-pandemic. And then similarly, we also are looking to do some sort of patient data aggregation with all the data that we have for patients across the world, that's just available in our system, and taking that data of different treatments that have been effective for different types of patient populations, given at age or medications that they're on, underlying conditions, and taking that information and allowing providers to have a more informed decision of some effective treatments that our system can detect before it's apparent to a human. So just taking a lot of those data points and making something meaningful out of that data. So any tips for folks who want to kind of go into engineering and follow this type of path? I'd say that one of the biggest things that was important for me was to not lose confidence. It's very easy to, it's a difficult field, challenging classes. So it's very easy to get discouraged along the way. I've definitely gotten discouraged along my academic career, but it was very important to use resources like your teachers, your classmates to keep pushing forward and not lose sight of kind of your intelligence and your abilities, and just keep pushing forward, since there are so many opportunities and ways that you can apply engineering and critical thinking skills in the world afterwards.
Thank you, all of you. Bob, could you jump in a little bit as you're listening to all of this? What connections do you see to the USM curriculum and opportunities? And having worked in the engineering field yourself, what are some other connections or particular skills that students can be developing and working on now that will help prepare them for the engineering field?
There was something I forgot where I ran into. I think it was a blog post in which someone this weekend talked about the concept of, are you a metal up person or are you a screen back person? And they were talking specifically in the software world, but I want to make it very clear that traditional engineering tends to look at the world from a metal up person. In other words, I first look at, if I'm looking at my computer in front of me, it has chips. What do those chips do? They're made up of registers. And then how do I program those registers by which I can make a software program, by which then I can learn algorithms by which. I think we're moving more in the future towards, and this is how my daughter ended up as a software engineer at Target, the screen back person, in which while that may be the traditional route, we are now moving into a larger set of subsystems by which we build for the customer. And Meredith, it sounds like your experience is very customer focused, and then you bring that back to the software. And I know that there's a subset of population out there that's extremely turned off from the metal up perspective. And I want to be very clear that actually a lot of engineering, and Andrew, you talked about this, is from the person to the product versus the product up. And so anytime, and Andrew, I'd love your advice as far as getting involved in teams, getting involved in groups, interfacing with teams, is helpful, because you're going to find that at least, I think I would know, at least half of the field, if you include the sales groups, are really people back sort of viewing. I also just got a book this weekend, and it's called The Art of Doing Science and Engineering, Learning How to Learn. Don't ever forget that really you're in school to learn how to learn. It's not about the content. And so, you know, if you can put that macroscopic lens on top of it, it really helps with dealing with all those times that you're like, this is really hard stuff, I just don't get it. It's okay. You're learning how to learn. That's the whole point of this matter. And then I just add that really it's any time that you can start doing, because engineers do. They don't, if there's no product at the end, there's no engineering, there's nothing to sell. And hence I look at things like Capstone, the innovation and design course, or the whole innovation transcript designation. I look at things like science fair, which anyone can do. You don't have to be in ISR to do a science fair project. So anything that you're just happen to be studying can be wrapped up in that sort of thing. I look at some of the courses I teach. You know, I teach a lot of project management in my courses because it is so important to be able to start from an area of no knowledge and grow to an area of actually, again, delivering on something. And know that I'm always here. So, you know, I was in the field for 6 years at Raytheon. I did SATCOM design. I did some line of sight network design and other design. And so if you want to talk about what is engineering, what is the path, what is a school, what is a co-op, what is an intern, you know, what is a 5-year master's, all that stuff, I'm here to help.
Thank you. A couple of questions. One thing that we often hear about is underrepresentation of women in engineering. And I'm wondering, is that something that in your programs or in the firms that you work with, do you see that actually reflected? How do you see that problem being addressed from the vantage point that you are in now, or do you even see it as a problem? I'll just open that up to everybody.
I'll go. I guess it seems to be a byproduct of the old way of thinking that, you know, science and math is for guys, and it's really not the case. Some of the better engineers and some of the better project managers in my engineering company that I interface with happen to be women. So I don't think it has to be that way. There's very, very smart and capable women in the field. It's a kind of a byproduct of the way people are brought up, and they're not encouraged to do that at a young age. So it's not even on their radar screen, unfortunately, which is it's a disservice to everyone. I mean, there's some very bright, capable minds that probably should be doing engineering that aren't even considering it because it's just not presented to them as an option. I don't think it has to be that way at all.
David and Meredith, did you, was there parity between men and women in the engineering programs that you were in?
So RIT, one of the things RIT is somewhat famous for is the RIT ratio, because it is very heavily tilted towards men. It's been getting better, and you know, every year it's gotten better, but it is still, I think the best we've been was like 60-40. And I will add that one of the things I have noticed is by far the majority of women in engineering that I've met, it seems like their parents are engineers and that's how they came into the field. So like was mentioned, it's just an old school thought process that really is preventing more diversity in the field.
Yeah, I'd say going through school, I did notice that there were fewer women. We probably had a 70-30 percentage split at Duke. And that kind of differed between the different engineering fields. So some of it was like 50-50, whereas others were 80-20. Really depended on which path we were going down. But I'd say it is changing to be more inclusive of underrepresented groups such as women. And I know that there are a lot of programs to try to get people interested at a young age. Like at Duke, we had a program called Girls Who Code. So it was a lot of women engineers who went into the Durham community to help introduce engineering concepts to younger girls. And I think also a lot of the women that I worked with or studied with, I think we just kind of like formed a group, and we liked the fact that we were some of the few, and we took pride in that. But we also obviously mingled with our male counterparts and didn't notice, like, it wasn't a barrier for the most part when we were working, which was really nice.
If you had to go back and give yourself advice about looking at engineering programs at colleges now, what advice would you give yourself? What should students be seeking in engineering programs? What are good ways to evaluate them?
So the way
go ahead.
The way I looked at it during my search was heavily into what school is going to give me the best potential exposure to actually be able to apply my skills before I have to go find a job. And that's what drew me, especially towards RIT. A lot of it was at RIT, you're in the lab your first semester, playing with circuits, learning everything. And that's something I didn't see at a lot of the other schools I was looking at. So by being able to get into the lab and actually apply skills on a breadboard pretty much from day one of your first semester, coupled with the co-op program and everything, it really just, to me, made the most sense because I would have the most opportunity to apply my skills before I had to go and apply them in the real world.
That's funny you should say that. I was gonna highlight, take a close look at the lab spaces. Mm-hmm. Anyone can teach textbook matter within reason, but the labs are really where you apply things. And when I went through Marquette, they didn't have the best lab spaces. Now they're, bordering on world class thanks to some of the renovations they've done in the last 10 years. And so the labs weren't the greatest, but one of my most rewarding experiences was in the lab working for a professor on an independent study, because there wasn't a class that interested me for one of my electives my senior year. So I was able to carve out an independent study with a thermodynamics professor, and I spent the semester integrating and setting up all the data acquisition for his two-phase flow test rig, which he was writing, technical papers and getting published on. I did all the sensor integration for that. That was my independent study, and it was time just to go tinker in the lab and integrate systems and crank the music on and get to work. It's just kind of get into the zone. I can tell David knows what I'm talking about, and it's great. You just get lost in there and you learn things. And you learn by getting your hands a little dirty and figuring out how things really work. So definitely look at the labs.
All right, it's 2:13 and we do need to wrap up. It feels very, very short, but thank you very much for taking the time. We appreciate you especially out of a work day to talk to students about what they can be doing to further their interest. If you have any further questions, students, please come find me. I'm happy to answer. I'm sure that Mr. Duranich is as well. And we wish all of you a wonderful afternoon. Thanks so much for being part of this.
Thank you.
Bye-bye.
Bye.